Okay, so we've got another set here, which is Cybernet 134. Let's look at the supplier mic. Da-da-da-da-da. Didcot, Oxfordshire. So we've got a hand-painted rot, is it? Rotel, no, it's a Radiomobile CB202. So it's as good as it gets. Something which started off at £119.99 when new. I think we'll sell him some new screws. There's nothing worse than the wrong screws. Especially when they use different screwdrivers to get them out. I think he must have told me via email what was up with it, but we'll see. Two of these screws feel like the wrong thread. Right, so we're inside. And so far, no nasty surprises. I can't see any capacitors which are... Well, I don't know about that one there. I think that one's going to have to go. It's looking like it's been for a circumcision. And that one probably in the amplifier is not far behind. Okay, well, it's handily got 4-pin 4mm plugs. So neatly plugs into our power supply. That's great. So pop the power supply onto 13.8 because we're doing that TRC 1012 handheld yesterday. I think we've got the surface mount part required for the other one. So on the back of his letter, and I'll just plug that in, I will start writing down the... Oh, I can't see which one's which, we'll guess it's that one. Switch on. Let's make sure these are somewhere. Oh right, it's dead. Oh, or am I doing something wrong? What a wally. Oh, it's so posh, it's a push button on this one. So we have received this. Whilst this meter's out, we'll do the VCO. So forget about anything else. Channel 40. Now, because we've put this to the power supply's 4mm plugs, I now don't have an earth. tell it to stay in there or something. So we want that there on an earth. Okay, so 3.98. What should we have on channel 1? Four volts. And on transmit, 4 volts. So it's very slightly high at 4.3. So we'll just do the trimmer for that. So receive 3.99, transmit 4.05. So that will do. We'll just check them on channel 1, 2.25, 2.31. So a little bit to the transmit there. I didn't see us having any transmit when I pressed transmit just then. Nothing came out into the test instruments, although it seems to be doing. You know what I've gone and done? I've got it plugged into the roof aerial. So I'm just transmitting all over the place. When I looked up the ammeter then, it clearly was transmitting because it said 900 milliamps. It's just doing about 3 watts. So we'll put the service manual back for a moment. Get his letter. Switch picture in picture on. I think we'll have it like we usually do there. And so I've got full scale deflection. It is 3 watts exactly. TX equals 3 watt. Deviation, wallow. Are we not tuned in? Wallow. Deviation equals wallow. It actually needs to come up an absolute fraction, but I want these controls in a precise place. That's in the right place. Just do that because it's so minutely out. Wallow. It's just actually very slightly low. So we'll do that. I'll still use the oscillator because it's easier. Just bring that up a fraction. Wallow. That's exactly where we want it. So it was actually 2.2 and we want it 2.22, absolute maximum of 2.5. So it we'll put that down. 2.1. Now 2.2 to 2.5. So that's done. Let's see if it's on frequency. So we're looking for 27.7. Oh, I mean, I'm on this. I've done this again. Doing it on channel 1 where we were checking the VCO. So are we on frequency? 7.9 watts. Drop that fraction as they do. So 79111. We just need to bring that up, that little fraction. It's not even, you know, hardly worth bothering, but I will do it for the sake. Oh wow, 27.79125. So that's fine. Because we checked the power on channel 40 by mistake, or channel 1 or whatever we did, I'll just recheck that. It's actually 2.8 watts. That tells us it's out of balance, which we do with clockwise, anti-clockwise. I think I'm keep being told by people. So we'll go back onto the main meter, and for the transmit, let's just bring that up. This is where we need the green tool. So I'm sure it's clockwise and anti-clockwise. I'm going to just have to check again. Memory like a sieve. T2, 3 and 4. Yeah, clockwise for the first. So first of all, we set them for maximum. So it's doing about 4.2. It's dropping off because as it heats up, they do. So about 4.5. So what we now need to do, it says 4, 8 and 9 for maximum, then rotate L4 clockwise to get 4.4 watts. So that's that one. Clockwise for 4.4. So we're detuning it to 4.4, and then the 30 L9 to anti-clockwise. They want you to set it to 3.8, but we'll be setting it to 4 because we're not having to get it through customs. They like to be over cautious, don't they? Certainly do with the new sets, don't they? With 2.7 watts and all that. So now we'll just check that it's somewhere near on the other channels. I wouldn't like it to be more than 0.1 out. So here's channel 40. It's virtually spot on 4. Here's channel 1. It's 4.1. But it soon dropped off again with the temperature. So it's pretty well balanced. So now we can tick that off. So I've done that. We'll just see what the receive is. Let's put the SINAD meter on and not drop the pen on the floor. And I'll just put that onto the here so we can see what it is. So let's drop the signal. It's 0.RX, it's 0.32 microvolts for 12 dB SINAD, so it's excellent. We'll go through that. We might be able to get a little bit more for him. We've had a few def sets recently. I've got that Midland 77805 which needs to go back to the customer. I'm going to do a scratchy corner on that. It is on a little bit on the def side, but within acceptable limits. It's about 1 microvolt. And one of the things we've discovered with it is that it went on frequency. Sorry, the sensitivity improved as the radio went off frequency. So let's say I've got the signal generator on channel 20, 2779125. If I drop that to 2779, instead of 125, 086 or something like that, quite a bit out, then the sensitivity improved. So as if it was off frequency internally. Well, the only thing that can send it off frequency really is the ceramic filter. So I changed the ceramic filter, and hey presto, it was improved sensitivity. So I reckon the reason that Midland is so immaculate is because it's never worked. Anyway, we're going to do a scratchy corner test on that, but I digress. So we'll start with the detector. Put an S9 signal on, and we'll put the oscilloscope to a suitable waveform. That's just across the speaker. Let's just see if that's maximum. Yeah, the tiniest little adjustment there, so that's fine. While we're on S9, we may as well see where the meter is. Oh dear. Oh, helps if we turn RF gain to full. That's going to affect the sensitivity. We'll recheck that. I hadn't spotted that. Let's put that to halfway as well. So we need that to be... That's dirty. I bet that one's dirty as well, because they always are. Never checked low power, did I? So I want it to be 3 dots. Then when I advance the signal generator just beyond S9, it does indeed light, which is what we want. So I'm now going to recheck sensitivity. I know we've adjusted the detector, but it was neither here nor there. Now we're at full RF gain. It was 0.32 before, it's now 0.27. I don't think we've been improving that. And whilst we're thinking about forgetting to do things, whilst we're remembering about the things we forgot, do the low power. So how do you switch that on? You know, you've got all these buttons and it's on the back. So it's doing 0.1, it's 100 milliwatts. So we'll just bring that to where it's somewhere where it should be. There we are, 400 milliwatts. It's useful. I think it's a useful feature, especially when you're in a convoy of cars and blowing each other's windows out. Good buddy. So we'll get back down to doing the receive. So we'll put the camera back on there, and we'll go through this. So we've got one there. Now we'll increase that a bit for the others. The hidden one under the wiring harness. Okay, see what we've got now. Okay, well we've got 0.24. Pretty incredible. Okay. We never checked the. Oh, we did the. No, we didn't do the RF meter, did we? Let's go back on that as well. So when I press transmit for all 4 lights, when I go to low power, it's supposed to be 1 light, and it's 2. So we just need to set that. The preset there. It's a bit dirty as well. I thought somebody's been smoking around this radio. Now back to full power. We should have all 4. We have. So that's set right. Squelch. So I'll set this for the. I will for the attenuator. We've got S9 at the moment. So we'll drop that, turn the squelch to full, and I want this to come in at 100 microvolts, which is S9 equivalent. 3, 10, 30, it's coming in too early. That's now coming in at 100, which is where we want it. So now we'll check the sensitivity end. Turn the signal generator to standby, and I've parked it at 0.3 of a microvolt. Set the squelch to threshold, switch the signal generator back on. Let's see when it comes in. So it's coming in at 0.55 of a microvolt, and leaving is about 0.45 of a microvolt. So that's absolutely fine. So there's 1 or 2 things need doing, and they may be done tomorrow. It's getting quite late on. 7 o'clock. We'll probably have to stack another set on here because I want to do a on the air test with that Midland, which I was just telling you about. So just needs those 2 capacitors changing, and I think we'll spray the volume control. It seems a bit iffy. So there we are. So far so good. Radiomobile 202. Okay, so back onto this radio, and let's put the power back on. I've done the 2 capacitors, and I've disconnected the power lead. That's why it's not coming on. Now both the capacitors I took out were 220 microfarads at 16 volts. Have been replaced by Nichicon ones at 25 volts and at 105 degree rated. Not that that's necessary, but it's what we tend to stock these days. I haven't got a ESR meter on here at present, but I'll just use the capacitor meter, and we'll just see whether there's anything amiss with this one. I'll drop the other one on the floor. Let's see what happens. 260. It's a bit high, and that can be indicative of failure, so never think it's a good thing. So that can go in the bin. The other one actually looked worse. So that's there and there. So where were we? We were putting the extension speaker back in so that we can actually hear it. And I've sprayed the front panel controls. So what we'll just do, it'll just make sure, I think it's green's negative on this. It doesn't matter which way the speaker goes in really, but let's just see if we can actually get it right. So I'll switch it back off again. We know the can's earth. Yeah, 0.9 of an ohm, and that's nothing. So that's that. Put that away. Not as big a speaker as that Banatone 5-star. might be doing another Harvard 404 home base tomorrow. We've got a surplus one and somebody wants to buy one. So I think we'll be doing 2 scratchy corner tests today. We'll do that Midland Porter Pack set, and we'll do this as well. Then this can go back tomorrow. So putting a whole set of 8 black screws in to look a bit better. So it's a very nice radio this. It was able to easily do the full 4 watts. It was able to easily develop the full deviation. I can feel my having to screw this in as it reforms the threads. I do have taps for ones that have been wrecked. I'm sure you've seen me use them. Sometimes we change the screws. There's some sets which use obscure ones like M2.5. We sometimes open those up to M3 using we drill it out and go through with the tap tool, which is handily just here. That's another one which you can feel has had the threads damaged. So there we are. We'll put it on the aerial. Might as well switch the test gear off and the soldering iron. And despite its well-worn condition, it works exceptionally well. One and a Roger. Yep, there we go. So we'll leave that on and we'll do an on-the-air test later on with Mr. Chippy. So thank you for watching the Radiomobile CB202 Cybernet 134 chassis set made in Japan from 1981.